Okay, so there's one last little bit of things that we want to talk about related to velocity before we move on to acceleration. So suppose you're driving along a straight highway that has a length of 100 kilometers. The time it took to make the complete trip was 55 minutes. And let's figure out what the average velocity was then. Okay, so all we really need to do, and let me just go to a blank space here. Remember, we know that velocity equals change in position divided by time. And our change in position was, and I don't really need to go through the whole process for this, the change in position was 100 kilometers. We went 100 kilometers, right? Our initial position was 0. Our final position was 100 kilometers. We went 100 kilometers in 55 minutes. Well, we don't like kilometers per minute as units. And so if I know that there are 1,000 kilometers in, or if there are 1,000 meters in a kilometer, I can multiply 100 times 1,000 and say that there are 100,000 meters. And then I know that in 60 minutes there are 3,600 seconds, right? 60 minutes times 60 seconds is 3,600 seconds. And then in 5 minutes, I know that there are 300 seconds. So I'm just going to subtract 300 from 3,600, and I'm going to get 3,300 seconds. And so what this means is that I'm going to go 33, no, let's get the calculator out here, right? Got to have the calculator. So 100,000 meters divided by 3,300 equals 30.3 meters per second. Okay, so 30.3 meters per second. Okay, so that's my average velocity. And so, does that mean we were going that velocity the entire time? And in fact, it would be very unlikely that we'd be going that velocity for the entire time. And by the way, that what we just did needs to go and answer 7 on your worksheet. Suppose that during the first part of the trip you were traveling 45 meters per second. All of a sudden, a police officer pulls you over for speeding and tells you that you were traveling 45 meters per second when you should have only been traveling 28 meters per second. And when the officer determined your velocity, did he actually measure your speed for several seconds and then find the average over those several seconds? Did he measure your speed for 1 second? Or did he just measure your speed for the tiniest instant of a second, right? Aims his radar gun at you, and immediately the answer comes up, you're going a certain velocity. He measured your velocity at an instant of time. And we call the velocity at an instant of time the instantaneous velocity. So if you look at the following diagram, in the first diagram, you can see that the velocity at all times is a constant 40 kilometers per hour. If I've got a graph that we're going to end up calling a velocity time graph here, I've got velocity on the y-axis and time on the x-axis. As I go, if I start, I'm starting at 40 kilometers per hour. At a tenth of a second, or at a tenth of an hour, I'm still at 40 kilometers per hour. At a 2/10 of an hour, I'm still at 40 kilometers per hour, and at 0.3 and at 0.4 and at 0.5 tenths of an hour, I'm always at 40 kilometers per hour. So at the instant shown by each of these labeled points, then my instantaneous velocity is also going to be 40 kilometers per hour. So we have a relationship between the velocity and the average velocity and the instantaneous velocity if the velocity is constant. So we can say that when the velocity is constant, the instantaneous velocity at any point in the motion will equal the average velocity. Okay, and that'll be a question on a test. Under what circumstance will the instantaneous velocity equal the average velocity? And the answer would be when the velocity is constant. If the velocity is changing, that goes away, okay? But if the velocity is constant, the instantaneous velocity, hopefully this makes sense, the velocity at any instant in the motion will be the same as the average velocity. So now if we look at the second diagram, we can see that the instantaneous velocities at each of the labeled points are 50 kilometers, so 50 kilometers per hour right here, 30 kilometers per hour here, 20 kilometers per hour here, 20 kilometers per hour here, and then 0 kilometers per hour at the last spot. So we're told after we measure all of this and then average it out that the average velocity in this scenario is 30 kilometers per second. So in the case where velocity is not constant, hopefully this diagram illustrates that instantaneous velocity does not usually equal the average velocity. So the average velocity is 30, and there's only 2 points here on this entire graph where the average and the instantaneous velocity are equal to each other. So in fact, the instantaneous velocity may only equal the average velocity at 1 or 2 instants in time. And so here at, somewhere between 0 and 0.1, I've got the instantaneous velocity and the average velocity at 30 kilometers per hour. And then over here again at point B, at time 0.2 of an hour, we've got the average and instantaneous velocity being equal to each other. But other than that, that's the only point in time during the entire trip that those two things equal to each other. So I want you to understand about the instantaneous velocity. It's the velocity at an instant in time. It's not a velocity taken over a long period of time or even just a few seconds of time. It's an instant in time. And we'll talk more about that later on. But also the only circumstance where the average velocity and the instantaneous velocity will equal each other throughout an entire trip is when the velocity is constant. As we can see here, when the velocity is not constant, it's uncommon for the average velocity to be equal to the instantaneous velocity. So just those 2 facts about the instantaneous velocity. These are graphs representing motion like this will be discussed in detail later. For now, understand that we make a distinction between the average velocity and the velocity that is occurring at an instant of time. We'll try to show why this is significant later on. Okay, so finally we're at the end of this discussion on velocity. We've defined it mathematically and in language. We've done several problems related to it. And we've learned how to begin our problem-solving strategy with a motion diagram and a given list, and then trying to find the formula that fits these pieces of information, and then how to solve the problem. And our next discussion will talk about what happens when velocity changes, and that's the topic of acceleration. So go ahead and go to the next topic.